A 3 ampere current flows along a segment of wire whose path is shown in the diagram. The segment is subjected to a uniform magnetic field that has a magnitude of 6 Tesla and points in the negative z direction. What vector force is experienced by the wire shown in the diagram? Okay, so this question is asking for vector force, which in this case is going to be a magnetic force, and it's given us the segment of wire, and it's given us the magnetic field. So the equation to find the magnetic force is going to be the force of the magnetic field is equal to the current times the cross product between the line segment and the magnetic field vectors. So let me rewrite over here. F sub B is magnetic field. I stands for current. This is the line segment vector. And B stands for the magnetic field vector. Okay. Now, looking at this problem, we know that the current is 3 amperes because it says a 3 ampere current flows along the segment. So this is 3. But we don't know what the cross product between the line segment and the magnetic field is, so we need to find this. But to find this, we need to find the vectors for both the L, the line segment, and the magnetic field. So to find the vector for the line segment, the problem says here that the segment of wire's path is shown in the diagram, okay? So this is the diagram, and the path is shown here, meaning that the line's path is going to be going from, because the arrow is pointing to the right, it's going to be going from this point to this point. So we could draw an arrow here. This is our line segment, okay? And the point, it's pointing this way. Now, to find the IJK components of this line segment, you want to see, okay, from this point to this point, how much in X value does this point have to go through to reach this point? So it has to go through 1, 2, 3. Okay, has to go to the right 3 times, right, as in within the x-axis. So our I component is going to be 3. Now, how much does it have to go from here so that it reaches here? It's going to have to go up in terms of y from 2 to 4. So to go from 2 to 4, you need to add 2. So the y component is going to be positive 2. And y component represents the j. Okay. As for the z component, aka the k, within the IJK format, because this is a segment, a line segment, it has only 2 dimensions. So it only has dimension here and dimension here. Z is non-existent, so Z is 0. So K is also 0, because K represents Z. Now, for our magnetic field vector, it says here that the segment is subjected to a uniform magnetic field that has a magnitude of 6 Tesla and points in the negative Z direction. So we know that I is 0, J is 0, but Z points in the negative Z direction, 6 Teslas, so it will be a negative 6. This would be our magnetic field vector, okay? Now we're going to do the cross product between the two. So set up our I, J, K. In the first level, we're putting the L line segment component. So we have 3 for I, 2 for j, 0 for k. In the second level, we're putting the magnetic field vector component, so we have 0, 0, negative 6, which means to find our cross product, the I component, we need to cover up the I. Multiply 2 times negative 6, you get negative 12 minus 0 times 0 is 0. This would be our I. For our j, we always put a negative here to find our j. Cover the j. 3 times negative 6 is negative 18 minus 0 times 0 is 0. This is our j. After that, we always add a plus here. For our k, cover the k. 3 times 0 is 0 minus 2 times 0 is 0. Okay, 3 times 0 is 0, and you minus 2 times 0 is 0. This is our k. So our cross product between the line segment and the magnetic field vector is going to be negative 12 minus 0 is negative 12, negative 12i minus a negative 18 minus negative 18. Two negatives makes a positive, so a negative and a negative makes a positive. 18j plus 0 minus 0 is 0. Okay, so this is our cross product vector, which means we can remove the question mark over here and write negative 12i plus 18j plus 0k as our vector. Now we can get the ball rolling. So let me erase this for more space. That way we could do our calculation. So we have the magnetic force is equal to 3 times negative 12 plus, no, always write your component. Negative 12i plus 18j plus 0k. All right, so 3 times negative 12 is negative 36. Negative 36i. 3 times 18 is plus 54j. 3 times 0 is 0. Okay, so this would be our vector and our units would be in newtons. And here is your answer.